Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. Could a rogue planet, an unseen titan colder than the darkest winter, suddenly emerge from the vastness of deep space and spell the end of Earth without a hint of warning? Imagine. One crisp evening, as you gaze at the familiar constellations, you notice something odd. A faint dark patch, a strange distortion of stars growing ever so slightly night after night. Scientists quickly mobilize observatories across the globe, but within weeks, panic sets in. Something massive and silent is approaching at unimaginable speed, something no telescope had ever recorded before. And this time it's not an asteroid, not a comet, it's a rogue planet. A world without a sun, a force too big to stop. It sounds like the perfect setup for a sci-fi disaster film, but it's grounded in real astrophysics. Rogue planets, sometimes called interstellar planets or nomad planets, aren't just theory. In 2011, a groundbreaking survey led by Takahiro Sumi and a team of astronomers at Osaka University shocked the scientific world when it suggested that there might be twice as many rogue planets as stars in the Milky Way. Using gravitational microlensing, a phenomenon predicted by Einstein's general theory of relativity, they captured fleeting glimpses of planets untethered to any star, free-floating through the galaxy. Later observations, including those from the MOA-2 and optical gravitational lensing experiment, known as OGLE, continued to reinforce this idea. Rogue planets are not rare, they're shockingly common. Gravitational microlensing works like this. When a massive object like a planet passes between a distant star and Earth, the planet's gravity bends and magnifies the starlight behind it, just for a brief moment. It's like nature's own cosmic magnifying glass. For a few hours or even minutes, the background star brightens and then fades again, telling astronomers that something invisible just passed in front. Through this delicate method, scientists have detected rogue planets ranging in size from a few times the mass of Earth to gas giants bigger than Jupiter. And because rogue planets don't emit light, don't orbit a star, and don't leave clear heat signatures, microlensing remains almost the only way to detect them. Here's where it gets even more unnerving. Unlike stars, which are large, bright, and relatively easy to track, rogue planets are nearly invisible until it's too late. If a rogue planet were moving toward our solar system at, say, 54,000 miles per hour, a speed within the realm of possibility, it might only be noticed once it was already within the outer reaches of the Kuiper Belt, the icy debris field beyond Neptune. By then we would have only months, maybe weeks to prepare, and preparation against a threat of that magnitude is frankly almost meaningless. But how did these nomadic worlds come to exist? Planetary scientists believe that in the early days of star system formation, around 4.5 billion years ago in our own case, young planets fought a violent gravitational dance for survival. Some formed too close to each other. Some grew too massive too quickly. When orbits overlapped or when larger planets destabilized their neighbors, smaller planets could be slingshotted out of their solar systems altogether, doomed to drift eternally. This gravitational bullying isn't rare, it's practically expected. In fact, simulations suggest that in dense star-forming regions like the Orion Nebula, entire populations of planets could be cast adrift every few million years. There are other possible origins too. Rogue planets might form directly from collapsing. Clouds of gas, much like stars do, but without gathering enough mass to ignite nuclear fusion. These sub-brown dwarfs, as some call them, would be born wanderers, never belonging to any star. Some theories even suggest they might harbor hidden subterranean oceans, heated by radioactive decay, raising the mind-bending possibility that rogue planets could carry primitive life across the galaxy, shielded from the void. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. Your curiosity fuels this mission, and together we can reach the farthest corners of imagination and discovery. Now let's confront the big question hanging in the darkness. Could a rogue planet actually destroy Earth? Would it crash into us, smashing continents into vapor? Or would the real threat come from its gravity alone, pulling at our world, warping orbits, ripping apart the delicate balance that allows life to exist? The answers are both fascinating and deeply unsettling. So how exactly could a rogue planet destroy Earth without ever even touching it? To understand that, we have to first grasp a chilling reality. In the intricate, delicate clockwork of our solar system, even the slightest nudge can be catastrophic. Imagine the solar system as a grand, ancient ballet. Each planet spins and twirls in a precise orbit, choreographed by the subtle push and pull of gravity. Earth's orbit around the Sun isn't just a random path, it's a razor-thin line between fiery incineration and frozen extinction. Shift that orbit just a few million miles closer to the Sun, and our oceans boil away into steam. Move a few million miles farther out, and Earth transforms into an icy wasteland, locked in endless winter. Stability is everything, and a rogue planet could shatter it effortlessly. Picture a rogue planet, a dark titan perhaps 5 times the mass of Jupiter, speeding toward our solar system at 54,000 miles per hour. It wouldn't need to strike Earth to doom us. If it passed within a few billion miles, say, near the orbit of Neptune, its immense gravity could destabilize the outer planets first. Uranus and Neptune could be dragged into new orbits, hurling ice and rock across the system like celestial shrapnel. Massive comets from the Oort cloud, a vast sphere of frozen debris encasing the solar system, could be dislodged, creating a lethal rain of fire that bombards the inner worlds for thousands of years. But it gets worse. As the rogue planet swings closer, it could begin warping the orbits of Jupiter and Saturn, our solar system's giant guardians. These gas giants play a crucial role in protecting Earth by deflecting or capturing incoming comets and asteroids, alter their paths, and Earth would become a sitting duck in a cosmic shooting gallery. In a darker scenario, the rogue planet's gravity might directly perturb Earth's orbit. Even a shift of 1 or 2% could be enough to trigger devastating climate change. A more extreme gravitational encounter could sling Earth out of the habitable zone entirely, or even eject us into interstellar space. Picture it, a frozen Earth hurtling alone through the darkness, with humanity's lights slowly flickering out as temperatures plummet to minus 100 degrees Fahrenheit. Death not by impact, but by exile. And yet, a direct collision isn't impossible either. Though rarer, if the rogue planet's trajectory aligned just right or just wrong, it could strike Earth head-on. The kinetic energy of such an impact would be beyond comprehension, releasing tens of millions of times more energy than the asteroid that wiped out the dinosaurs 66 million years ago. Mountains would vaporize, oceans would boil. The very crust of the Earth would liquefy into a hellish ocean of molten rock. Humanity would cease to exist within minutes, but perhaps the most terrifying aspect of all is this: we might never see it coming. Rogue planets are so dark, so cold, and so isolated that traditional telescopes struggle to spot them even when they're close. Unless a rogue planet happened to pass between us and a bright star, allowing microlensing detection, or unless we built a vast new network of infrared observatories sensitive enough to catch their faint heat, our first sign might be a distortion in the orbits of outer planets, or strange anomalies in the Kuiper belt. By then, it could already be too late. Some scientists believe that subtle signs could tip us off. Astronomers are constantly refining techniques to detect gravitational anomalies, small wobbles or shifts, in the paths of known objects. If Neptune orbits just a fraction slower or faster than expected, it could hint at an invisible mass approaching. Yet interpreting these hints would take time, and that's the one resource we might not have. There's historical precedent for cosmic chaos too. 400 million years ago, during what scientists call the Late Heavy Bombardment, the inner solar system was pummeled by a furious rain of asteroids and comets. Some theories suggest that a rogue object, perhaps a migrating gas giant, destabilized belts of debris, triggering this apocalyptic era. Life barely survived, and much of Earth's original crust was obliterated. Today we live in a comparatively calm solar system, but that peace could be an illusion, a fragile moment between storms, and there's something else to consider. Some models suggest that rogue planets could still be lurking within the outer boundaries of our own system, hidden beyond Pluto, beyond the Kuiper Belt, in a region called the Scattered Disk. Astronomers even have a name for the hypothetical, massive object they suspect is out there, Planet 9. If Planet 9 exists, it could be an ancient rogue, long since captured by our sun's gravity, a sleeping giant in the distant dark. If one rogue world could already be lurking at the edge of our solar system, could another be closing in right now? Now we'll explore the scientific debates about just how likely a rogue planet encounter really is, and what humanity could do, if anything, to defend ourselves from such a cosmic threat. Because survival, in the end, might depend not on brute strength, but on foresight, technology, and the courage to face the unknown. So how likely is it that we'll actually face a rogue planet? Could our technological advancements, our ability to detect cosmic threats, ever be enough to stave off such a disaster? The odds might be low, but the consequences are so extreme that even a faint chance demands our attention. First, let's talk about the numbers. The Milky Way galaxy is home to around 100 billion stars, and estimates suggest that there could be a similar number of rogue planets wandering in the dark without a parent star to guide them. But here's the thing. Just because there are billions of these objects out there doesn't mean we're in immediate danger. The vastness of space is beyond comprehension. Even though rogue planets could be numerous, they're scattered throughout the galaxy, far away from our solar system. In fact, even if a rogue planet were heading toward Earth, it would have to cover millions of years of travel to reach us. That's the good news. However, there are several factors that make this scenario more terrifying than it might seem on paper. Rogue planets move at incredibly high speeds, tens of kilometers per second, faster than anything we can launch from Earth. That means if one were to cross our solar system's path, we'd have very little time to react. Remember, the Milky Way itself is a vast, sprawling cosmic neighborhood, and we, like many other planets, are in motion. Our solar system orbits the center of the galaxy at over 500,000 miles per hour. Any rogue planet coming our way would need to cross this motion, but the chance of that happening, while slim, is far from impossible. A stray world, even with a low probability of intersecting our path, could end up in our solar system, drawn by the gravitational influence of passing stars or intergalactic events. So the universe doesn't necessarily need to target Earth to make this nightmare a reality. It only needs to set the odds in motion. Now, what about our current ability to detect these rogue wanderers? Here's where things get tricky. We already have some powerful tools at our disposal. One of the most promising is the Wide Field Infrared Survey Explorer, WISE, a NASA mission that scans the sky in infrared wavelengths. WISE has detected numerous objects within the solar system, and although it's not designed specifically to detect rogue planets, its infrared capabilities could theoretically spot the heat signatures of gas giants or rocky worlds traveling through the void. The problem is, a rogue planet's infrared glow would be incredibly faint, especially if it's far away. It could slip under the radar for years, even decades. The James Webb Space Telescope, JWST, which launched in 2022, has far greater resolution and sensitivity than any previous instrument. If we catch a rogue planet early, JWST could be a game-changer in terms of detecting its presence. However, even this revolutionary telescope would need to be aimed precisely at the right location, and its ability to track a fast-moving object across the sky isn't guaranteed. That leads us to the real question. If a rogue planet were detected, on a collision course with Earth, what could we do? The short answer is, right now we don't have much to work with. Humanity has no established defense against rogue planets, and our current space programs are focused on more immediate threats, like asteroids and comets. Unlike asteroids, which we can sometimes divert with nuclear devices or by using spacecraft to nudge them off course, a rogue planet's immense gravity and sheer size would make such methods ineffective. So, let's imagine a scenario where we have a few years, say a decade or two, to prepare. What might we try? The idea of nuking a rogue planet to change its trajectory seems outlandish, but it's one of the first things that comes to mind when we think of large-scale space interventions. The problem is, The amount of energy needed to move a planet, even one the size of Earth, is beyond anything we've ever conceived. Not even the largest nuclear bombs would have much of an effect on something as massive as a rogue planet. Even if we detonated hundreds of nuclear warheads, we'd barely cause a ripple in the fabric of its motion. Could we build giant thrusters and push the planet off course? The idea sounds like science fiction, but it's not entirely impossible. Some scientists have proposed using massive solar sails or ion thrusters to slowly push objects in space. But we're talking about building something on an astronomical scale, essentially a spacecraft the size of a city, possibly even larger, just to nudge the rogue planet's path. The resources required would be beyond the capability of any space program we have today. Plus, there's the issue of timing. We would need to detect the rogue planet far enough in advance to set such a plan into motion. Then there's the orbital alteration theory, where we could attempt to modify Earth's orbit to avoid a collision, but again, this would be an enormous undertaking. To make any difference, we'd need to move Earth by millions of miles, which is not a task even 1,000 years of technological progress could likely achieve in time. The only solution would be to develop vast new technologies, ones we can't yet fully imagine, but which might become a reality if we're willing to invest heavily in research, both in space travel and physics. But perhaps the most practical option in the short term would be the evacuation of Earth. Yes, it sounds extreme, but if the threat was detected early enough, humanity might have the option of sending people to other planets or moons, perhaps to Mars or even to the outer moons of Jupiter or Saturn. Colonizing a new world would be a daunting task, requiring the construction of self-sustaining habitats, advanced space travel technology, and an unprecedented effort to leave Earth's cradle. But if a rogue planet were coming for us, this may be the only realistic way to preserve human civilization. Of course, that brings us back to the fundamental question: is it possible to predict a rogue planet's path? Could we track one down early enough to save ourselves? The truth is, no one knows. Despite all the technological marvels at our disposal, the chances of spotting a rogue planet in time, especially one traveling at high speeds through the galaxy, remain a long shot. But the pursuit is far from futile. By creating an international effort, pooling our best minds and resources, humanity might one day be able to track these interstellar wanderers and, who knows, even protect ourselves from them. Now we'll take a step back and ask some profound questions. Should we live in fear of rogue planets, or should we embrace the mystery of the universe as a part of our cosmic journey? Could the search for these dark wanderers open up new frontiers of space exploration and survival? The answers might surprise you, and the journey might just be beginning. As we stand on the precipice of this vast, unknowable cosmos, we are left with a question that haunts every explorer, every dreamer. Should we fear the rogue planet, or should we embrace the unknown mysteries of the universe as part of our journey? It's easy to be consumed by the darker possibilities. The image of a dark, wandering planet, capable of erasing civilizations with a mere gravitational nudge, can easily provoke a sense of dread. The raw power of these rogue wanderers is unsettling. They are cosmic nomads, drifting freely through the galaxy, untethered by stars moving like silent hunters through the cold night. The sheer unpredictability of their path makes them formidable adversaries. After all, if we can't track them, how can we defend against them? But if we shift our perspective, something else emerges. The rogue planet's mystery is part of the grand tapestry of the universe. We might view rogue planets not just as harbingers of doom, but as something more profound. They are ancient travelers, witnesses to the birth and death of stars, remnants of cosmic processes beyond our comprehension. They carry with them stories of star systems that never were, worlds that broke free from the gravitational pull of their parent suns and set out to wander the void. They are part of the eternal journey of the universe itself, and in some ways, we are a part of that journey too. Consider this: we live on Earth, a small fragile oasis in the infinite void of space. We've survived through millennia, enduring glacial ages, asteroid impacts, and the rise and fall of civilizations. Our very existence is a miracle, a spark in the darkness. In many ways, the rogue planet represents that ultimate unknown, the one force we can't control. It's a cosmic reminder that no matter how advanced we become, we are still part of a larger, unpredictable universe, and maybe that's not something to fear, maybe it's something to respect. Rogue planets are reminders of the universe's infinite possibilities, both destructive and awe-inspiring. They remind us of the delicate balance of our existence, of the finely tuned parameters that make life on Earth possible. They also remind us of the boundless curiosity that drives us to explore, to understand, and ultimately, to survive. In a sense, our response to these threats could be the greatest expression of human ingenuity. Could we build the technologies needed to detect rogue planets and prevent their disastrous impact? Could we colonize other worlds, ensuring that humanity lives on, even if Earth itself is no longer habitable? Could we, as a species, evolve to the point where we are not just survivors of Earth, but explorers of the cosmos? These questions echo through the ages, guiding our journey into the future. We already see signs of this curiosity and drive for survival. The space race of the 1960s showed us the boundless potential of human innovation, and today private companies like SpaceX and Blue Origin are pushing the frontiers of space travel further than ever. Missions like NASA's Artemis program, aimed at returning humans to the Moon, and the goal of sending people to Mars, show that we are already laying the groundwork for future colonization of other worlds. And who knows, in the coming decades we might develop technologies that make living on other planets not just a dream, but a reality. It's not a question of whether a rogue planet will arrive. Instead, it's about how we prepare for the unknown. The rogue planet could be a metaphor for the greatest challenges humanity faces. It's a reminder that, even when we think we've mastered the world around us, there is still so much we don't understand. And the journey to unravel that mystery? It's the essence of exploration. It's what pushes us to build telescopes that peer deeper into space, to launch missions to the farthest reaches of our solar system, to develop new technologies and reach for the stars. What if our greatest threat isn't something we should fear, but something that pushes us forward? A rogue planet, with its silent, indifferent approach, might be the perfect test for humanity's adaptability and resolve. And what if that test leads us to places beyond Earth, to worlds we've never dreamed of? In the end, this cosmic nomad might become the catalyst for something far greater, the next chapter of human evolution. Imagine a future where humanity thrives not just on Earth, but across the stars. A future where our descendants, equipped with the knowledge gained from confronting rogue planets, live on distant worlds, forever expanding the reach of life in the universe. The rogue planet, then, would be not a destroyer but a herald of new beginnings. So the next time you look up at the stars, think about the rogue planets, the dark wanderers that drift through space, indifferent to our existence. Think about the vastness of the universe and the incredible journey that lies ahead. Maybe, just maybe, this mystery will be the spark that lights the way to our future. And before we end, I'll leave you with one final question. What are we, if not stardust on a journey to the unknown? Should we fear the cosmic wanderers, or should we embrace them, knowing they're pushing us toward a future we could never have imagined? If you've enjoyed this journey into the mysteries of the universe, don't forget to hit like, share this video with fellow explorers, and leave your thoughts in the comments. What do you think? Could humanity survive a rogue planet encounter, or should we focus on reaching for the stars instead? I'd love to hear your thoughts. Thanks for joining me on this cosmic odyssey. Until next time, keep exploring, keep wondering, and keep looking up.